Hello everyone. Welcome to the section 7.2 CDIO implementation of the 17 CDIO International Conference. My name is Ulavit Tangkiwat and I will be a chair in this section, which will be run 1 hour from now. In this section, we have 4 talks and every speaker will have 5 minutes for their presentation by pre-recording video or live presentation, followed by 8 minutes for Q&A. For the audience, you can drop your question in the chat box, and also you can verbal ask after speaker finish talk. For the first presentation, I'm not sure she already into the room. Miss Sing Yan Lee, are you here? I would like to check in the participant first. Okay, for the first speaker, she not yet to come to in the room. I would like to move her presentation to the last, and I will move to the second speaker to the first speaker. The first speaker is the Professor Valavel. I'm sorry if I pronounce your name is mistake. From the SRM Institute of Science and Technology, India. He worked in the SRM Center for Applied Research Education and is also a senior IEEE member. Now he will be talking about e-practice environment to learn programming for problem-solving course, paper number 129. Let's see his presentation.
Thank you. Good afternoon and greetings from SRM Institute of Science and Technology, one among the premium universities in India. I am Professor Vairavel, working in the Center for Applied Research in Education. This pandemic has taught us how to work, study, meet and attend events remotely. This has helped us to be more creative, collaborative and also helped to find our inner strengths. As academicians, this pandemic has brought out the best in all of us to search, find and utilize all available web-based learning tools. All of us have evaluated many software applications, their utility and suitability in higher technical education than ever before. It is in this context that we created this e-practice environment for the popular problem-solving course. The problem-solving course is offered to all undergraduate first-year students in our university, numbering more than 20,000. This course is unique and crucial that the learners have to logically and thoroughly analyze the given problem scenarios, then design, implement and execute solutions using programming languages. Problem sets posted are real-world scenarios presented in an increasing order of solving complexity. The main objective behind this course is to develop logical thinking abilities of higher order and latent thinking for problem solving. These are much needed skills for all graduates. The other objective is also to develop programming skills. To build a remote access e-practice entity, we identified the following requirements. Should support D, I and O of the CDIO framework. Learners should be able to use any internet-connected digital devices that they currently possess such as phone, tab, laptop, desktop, net-connected TVs, etc. Solving problems can be using any web browser in any operating system. There shall not be any application or software to load into the devices. Rather, they could access the entire e-practice tool via a simple web browser. Should not consume much of the 3G or 4G data bandwidth that would tax the limited connectivity available to rural students. Should support our existing technology, pedagogy and content knowledge, that is TPAC curricular framework. Should have support to compile C, C++, Java, Scilab, Octave, Python, Haskell, Lua, Swift, Rust, Julia, JavaScript, R, Ruby, C Hash, Perl, Clojure, Go, Shell script and SQL programming languages. The e-practice environment should not be a simulator or virtual entity, rather a remote access real-time environment. Problem-solving questions shall invoke one or more of the logical thinking abilities such as inductive, deductive, abductive, defeasible, statistical, probabilistic, and reflective reasoning. The problem-solving questions shall provoke exploration, imagination, and creativity. The posted solutions for the problems shall be auto-evaluated, thus reducing the strain on teachers who otherwise have to physically go through every possible solution put forth. The e-practice tools shall support student login and interactions, faculty login with batches assignments, Coordinator login with problem entry and report generations. The e-practice environment shall be developed only using free and open source technologies. Tools should support peer-based learning, active collaborative learning, mobile-based programming strategies, problem-based learning, and case-based learning. In order to provide the assistance to students based on their needs and knowledge level, the problem sets should be structured from simple to complex. The e-practice environment's main focus is on determining how people learn and on how to help people in learning. The tool is built as a client-server model, with the server hosting all the required program compilers and the front-end client with responsive interface screens. The server-side modules includes the content management system, learning management system, and remote access programming environment. The CMS contains the problem statements and the test cases for program correctness verification, such as visible test cases, invisible test cases, and mandatory test cases. The LMS contains the solution program evaluation model, and it provides 5 learning activities such as solution to problem, solution code debugging, solution code shuffling, solution code snippets, solution code matching. The course facilitator can define and create new problem sets, and for each problem set, they can define the problem statement, its test cases. A simple user interface for the problem statement is provided. An editor workspace is provided to solve using programming languages. Learners can solve the given problem using any of the programming languages of choices. The solutions are compiled in real time in the server, and status of the solution is updated daily. The overall problem statements are divided into 10 topics, and in each of these topics problem statements are provided. Every learner registered with ePractice tool are provided with a total of 300 problem statements randomly assigned from a pool of 2500 plus statement repository. These 300 problems are divided into 100 problem statements, each of 3 levels, say easy, medium, and hard. The course facilitator can see the progress of each learner and their levels of completion. The facilitator can identify learners who are struggling and the ones who are smartly solving. This helps them to dedicate their time in identifying and mentoring the academically challenged learners, so that those learners can duly develop their logical reasoning abilities and also their programming skills. Some of the key benefits for both the learners and facilitators are listed here. The main purpose of developing and utilizing the ePractice tool was to help students to continue their learning curve despite all odds created by the present pandemic. This ePractice environment was deployed for the learners of our university who have registered for study under the regular distance education and online learning modes. During these pandemic times, we have reached out to more than 20,000 students for continuing their learning despite all restrictions. Personally, as the creators of this entity, we feel immensely happy to see learning continue in these difficult times. Thank you.
Thank you very much for your presentation, Professor Valavel. Now is the time for the question or suggestion, please. Okay, for me, in the first question, I would like to ask you about what kind of difficult point in online practice and how do you manage?
In terms of implementation or in aspect of the students?
Mm-hmm.
In which aspect you are asking? Which difficulty in terms of implementation or the difficulties faced by the students? Yeah, there's a question like what is the percentage of time spent on problem solving out of the total learning period? So actually, this particular problem solving is being done offline. Online. The faculty used to teach the course during the session, and the problems has to be solved by the students during their own period. So they will be given a particular tentative time period so that to complete a set of problems, so that within the time the students have enough time to complete all the problems. And this particular online tool will try to record the time that is consumed by the students to solve the problems. So that will try to rank the students who have taken minimum number of time and less. That is, we have our own evaluation, like how effectively they code the particular problem. Such kind of things will be evaluated by the faculty in the back. Yeah, the system is developed in-house by a team of faculty. So we have developed the entire system through the open source tools available. We have developed it.
We have the question from the Professor June asked you in the chat box. She said that do you analyze the result and group them in different schools?
Do you analyze the results and group them in different groups? Actually, this is evaluated. Each individual student's progress is evaluated, and the appropriate comments and the improvements will be suggested to the students individually. And also, actually, each student is given a individual login, and their track record will be monitored individually. And also, there are certain cases we will use to group the students to, and we will post the problems where the students will collaboratively try to solve and give the appropriate answer. That is also possible. So we have two modes. One is of practicing environment, which the students will solve individually. And there are some case-based problems where the students will be grouped together and they will try to solve it. So that is also possible to group it together and solve it and be available.
And another question is, what is the percentage of time spent on problem solving out of the total learning periods?
Yeah, I have answered it before because the faculty will try to set up a time period to solve a set of problems. So there are three levels: level 1, level 2, level 3. Level 1 will be of less complexity, complex problems. So it will be the levels will be of more complex problems. So the level 1 will take very less time to complete because it is of preliminary level. So when the level goes up to the higher level, the students need much time to solve the problem. So this tool will record the time consumed by the students when we logged in and when we start attempt coding. The tool will try to record the time taken by the student to complete the program, and also it has got the capability to check when is there any plagiarism or program being copied by the another set of students. So we have here some test cases and to check and validate the program whether it is appropriate.
And do you have information how about the student feedback to the e-practice tool that you make it?
Yeah, we have a feedback mechanism embedded in the tool, and also the students directly can give the feedback to the faculty, as well as they have a online feedback tools also where they can able to record their feedbacks. So we will try to continuously improve based on the students' feedback and improve the learning. So there's a question like, for the first years, was it a challenge for you to ensure the understanding of the fundamentals before the Yeah, actually, here the thing is, in India, actually the programming is being taught from the school level. So they are exposed to Python and C programming in the school level itself. So the students are given during the first year, the students are initially given an introductory session and practice sessions with level 1 kind of a problem solving using the tool. So after understanding the students' capabilities of programming and try to teach once again with clarity, they will be allowed to solve the problems at higher complex levels. So since it is a continuous process, the problems, the challenges are overcome because of two-way interaction with faculty teaching as well as online practice.
Any question from the floor?
Yes, this is used for assessment also. This is not only for practicing, this is also used for assessment. So we actually during this pandemic time we have conducted the assessment using this tool, and so the question is being the faculty has the ability to the practice environment has got a set of questions, and during the assessment it is possible to load the questions set by the faculty, and the assessment shall be conducted. Yeah, it is. If the institute is interested, we are ready to help in developing this kind of thing.
Any more question from the floor?
Thank you.
Okay. Thank you very much for the professor. And the next speaker is the Miss June Tan from Singapore Polytechnic, Singapore. She is a specialist in AI and analytics. Today, she will be sharing about application of CDIO skill in artificial intelligence and analytic projects. Paper number 85. Let's see her presentation.
Thank you. I'm Teck Jun of Singapore Polytechnic. This paper explains the application of CDIO skills in AI and analytics projects. The aim of the project module is to provide students with an opportunity to integrate and apply knowledge and technical skills to real-world problems in their two phases in this project module. Lead review E. Crawley in 2014 stated that besides a good command of technical knowledge, our graduates must also be equipped with a range of personal, interpersonal, professional, and engineering skills. Singapore Polytechnic has adopted the CDIO syllabus in the course curriculum. There are 3 research questions. Did the students have the ability to apply professional skills to their project? Did the students have the ability to apply interpersonal skills to their project? And did all team members contribute fairly to the project? A questionnaire was administered to 40 third-year DBIT students. The aim of the questionnaire was to find out the students' perception on the application of the professional and interpersonal skills to the project. In total, there were 22 questions, 18 closed-ended questions and 4 open-ended questions. Here is a summary of the survey results. Teamwork skill ranked the highest with a mean score of 4.68. It is then followed by communication skill with a mean score of 4.59 and analytical reasoning and system thinking skills with a mean score of 4.58 and attitude in learning with a mean score of 4.54. Question 7 to question 11, they are on analytical reasoning and system thinking skills. 26 of them strongly agreed that they are able to identify key features of the project. Question 12 to question 15, they are on attitude in learning. 21 students strongly agreed that they are able to demonstrate professionalism and integrity when they are working on the project. Question 1 to question 3 are on teamwork skills. 25 of them strongly agreed that they can collaborate very well with team members. Question 4 to question 6 are on communication skills. 23 of them commented that they listen actively to team members and they will respond to all questions by clients. There are 4 challenges that students encountered when they are working on the project: lack of technical skills, poor time management, and unclear user requirements. An online assessment tool was adopted to evaluate team members' contribution. The tool calculates the SPA score and SAPA score. For SPA score, students evaluate their peers' individual contributions to group work and themselves. For SAPA score, it gives an indication of how realistically students judge their individual contribution to the group project. It is heartening to hear that 87.8% or 29 students, they actually contribute to acceptable and good teamwork. And there were 2 or 6% of the students who contribute very little to the group work. 51% or 17 students believe that they do more in the group project than their group members thought. 1/3 or 10 students undervalued their contribution to the group project. With the quantitative and qualitative comments, supervisors would actually provide feedback to students so that the entire team could contribute effectively to the successful completion of the project. Conclusion: students were able to integrate the knowledge and skills learned in their core modules and apply to the project. And interpersonal skill ranked higher than professional skill by 0.075. Use of online team-based self and peer assessment tool is highly recommended. And here are the 3 areas for improvement. Students to set aside 2 weeks to attend technical workshops, and supervisors could teach students time management, and supervisors could guide students on how to translate non-specific client requirements into system design specifications. Thank you very much.
Okay, Miss June, thank you a lot for your presentation. Welcome to the question and suggestion. A few days ago, Eileen asked you in the Huwa app. Eileen, you can ask her directly.
Okay.
Yeah, it's in the chat.
Yeah, so actually Eileen asked about the, it's in the chat, talking about whether the students are able to integrate the modules they have learned in their core modules to this final year project. So yeah. I have already answered the question, say that yes, it is heartening to hear that the students actually had 28 modules for this diploma in business information technology. And it is heartening to hear that they are able to apply soft skills like teamwork and communication skills and technical skills like programming and analytical skills into their project. And you can see that the students are very good. They're able to conceive, conceptualize the idea, able to design a proper system, and able to implement the system for our clients. Thank you.
Any question?
I have one question.
Yeah.
Please.
Could you please explain the difference between SPA score and SAPA score?
Okay. I have the SPA stands for self assessment, self and peer assessment. Means that let's say the group have 5 students, 5 of them do an evaluation on you, and you also do evaluation yourself. Basically, you have 5 students, you are one of them, you do an evaluation on others, others do an evaluation on you. There's SPA score. So the SPA score is best to have the value of about 1. That's the best, means that you have contributed sufficiently to the project. SAPA score stands for self-assessment over peer evaluation, which means to say that you think your contribution to the project. So if the SAPA score, self-assessment over peer evaluation, assuming it's 1.4, okay, let's say my SAPA score is 1.4, but my SPA score is 0.7. Well, that is not very good, which means to say that I think that I've contributed a lot to the project, but the peers think otherwise because your score is so low, 0.7 only. So with this kind of score, then the supervisor will talk to the whole group, and especially the students say, you think you have contributed a lot, but from your peers, you have contributed only so much.
Thank you for your answer.
Thank you very much. Yeah.
Any question?
So I find that in Singapore Polytechnic, whenever there are group assignments, we will always initiate this self and peer evaluation, because it is very common that we have project work whereby the project can be 3%, okay, or it can be 4%. So in order to award the marks duly, like award a grade A, grade B, grade C, grade, then we will look at the peer evaluation together with the qualitative feedback from the students, which is very important. Yeah. Okay, there's a question here. Interest. Do you think there should be a? Is this a question? Yeah. Do you think there should be an optimum mix of those skills in the engineering project? Is this for me? Is this a question? From
yes,
Prof. Okay. Okay, so
Yeah.
your question is, do you think there should be an optimum mix of those skills in the engineering project? Yes, there should be a mix of skills, soft skills and technical skills, yes. For this kind of project, yes. So usually talk about disciplinary, multidisciplinary projects. It's good to have multidisciplinary people, from different discipline to work together. But for the School of Computing, all the students are actually from the same diploma. So we will, all the students will study the School of Computing are from the same course, so they work together. So for multidisciplinary, no, multidisciplinary is only practiced in another module, social innovation project module, where they use design thinking methodology. Yes, that one really multidisciplinary, whereby I'm also into design thinking methodology. Really multidisciplinary, yeah. You people who are good at communication skills, people who are good at technical skills, and then people who are very good at video skills. Yeah, really multidisciplinary. Thank you very much for your question, Prof. Prasanna.
Any question? I have one question. From your result of the teamwork contribution, you found two lazy guy, right?
Sorry, repeat.
Your result of the teamwork contribution. You found two lazy guy.
Oh yes.
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 What they are feel in the group, or you have any more information from them?
Okay, so I think you are referring to the SPA. You're referring to the score, right? They have given to you, which is SPA score. Whereby there are two of them who are lazy. Okay, so what happened is that because I know all my students, okay, the final project. So these are the students who just happy-go-lucky one. They just want to get by, and they are really not motivated to do well. They just want to pass the module. So unfortunately, in the class of 40, you will have one or two this kind of students. Yeah. So what happened is that as a lecturer, for example, if I'm the supervisor, I will want to know more how to help him. So sometimes it's because they have their own personal problem that they are not able to cope. Then as lecturer, I will try to extend my help if it is my group to help them.
Yeah. Thank you. And
it's good that a lot of them actually try to do well, because it is one of the last semester. Last semester means all the students wish to make sure that their scores, their total scores is called semester average score is very good, so that they can go to university. So a majority of them, can say 80 or 90% of them, would try to do very well so that they pull their score up, because it is considered as a 17 credit units. It's very high. Yeah.
Okay, the last one from the Ellen, she asked you about how frequency is the peer evaluation done.
Okay. So for peer evaluation for final year project is a project module that lasts over one semester, and it is 17 hours credit units, and the peer evaluation is done twice. One in phase 1, week 7, and another one in week 15. It will be done twice. So what happens is that when the first time a peer evaluation is being carried out, then the lecturer will take a look and say, okay, there are cases whereby there are students who are not putting a lot of effort. Then the lecturer will approach the student, and hopefully the last one, which is a phase 2 peer evaluation, is better. Then from there, we know, okay, so the student actually, know that he has contributed so little, so he better buck up so that his results is better.
Okay, thank you very much.
Thank you very much. Yeah. Thank you very much, Prof. Urasis.
Yeah. Now we are going to the next paper. Miss Imani Abutajadin is a PhD research in the engineering education at the CD Mohammed bin Abdullah University, Morocco. She will be talking about effective initiation to CDIO framework using design thinking, the DICO process. Paper number 127. Miss Imane, please share your screen and start presentation.
Okay, thank you. Are you able to see my screen now?
Yeah, I already.
Nice. Okay. So, hello everyone. My name is Imane Boutasdin. I am a PhD researcher in engineering education at Sidi Mohammed bin Abdullah University in Morocco. And together with Professor Ahmed Boutasdin and Yassin Salihaj, we are suggesting a new way to initiate faculty to the CDIO approach using design thinking. And I think that we are all seeking to improve engineering education at our institution. And as many of you, we all consider that adopting the CDIO framework could definitely help us better prepare future engineers to the job market. And we assume that this is not an individual effort. We need faculty from the institution to adopt the CDIO approach. And also we need to encourage them to work collaboratively for the success of implementation of the standards, such as integrated curriculum. But given time constraints and workload, it becomes hard to find extra time to invest in new initiatives. So what is challenging here is how to embark faculty in the CDIO approach in a way that captures their motivation and interest to change while experiencing CDIO strengths. And moreover, as the student is central to the approach, how can we help educators focus on the student needs? So what we suggest is to introduce them in an actionable way through the workshop to experience really CDIO. And in the workshop, they have to find solutions to problems at their institution using the CDIO approach. But how to do this? For that, we developed a design process which is based on CDIO rationale and human-centered design to take into account the student needs and help educators discover the CDIO approach more in a doing mode. And the reason why human-centered design or design thinking is used here is because it provides a comprehensive structure to investigate a topic framed as a problem. And the process is called DICO with reference to CDIO, but reversing it in a new way, which is discover, ideate, create, and operate. Now, let's see how the process works and how the workshop is organized. So teams of educators will be introduced to the CDIO framework, and they will work in teams, and they also need to know what the challenge is. And after that, in the discover phase, they need to do internal research to understand the problem at the student and institutional level. And after that, they are given the syllabus in order to select the intended learning outcomes depending on the identified need from the research. And in the ideate phase, they will formulate new opportunities as potential directions to tackle the problem. And they have also to explore the CDIO standards for inspiration in finding solutions. And yeah, we can provide them as well with case studies for inspiration. And after that, it is time to come up with ideas and select promising ones. And at the end of this phase, they have to share their ideas and share the key learnings from the CDIO standards with their peers. So in the create phase, they have to select one idea and prototype it, means making it tangible, and need to know what are the ILOs that this idea is achieving. And in the next phase, they have to present the idea and prepare an implementation plan. So operate here is more for like a preparation to the implementation rather than having the whole idea and just maintaining it. And in the last session, they will be given input on how to join CDIO and how to get prepared. And also it is interesting to show them success stories in CDIO, but more in similar context to their institution. So overall, faculty needs to be involved in the change process, and it is necessary to introduce them to CDIO in an actionable way to motivate them to learn more about the initiative and be able to implement it. And in this work, we suggested a workshop to initiate faculty to CDIO framework using design thinking. And that's it from my side. Thanks a lot for listening. This was Iman Abu Tasdeen from Sidi Mohammed bin Abdullah University of Fes in Morocco.
Thank you very much for interested talk. We will welcome to the question or suggestion for.
Okay. May I ask the question?
Yes.
Yes. Okay, thank you for your presentation. It's very nice presentation. And I would like to ask you about the results of the last step that you talk about the presentation from the student to show how to join CDIO initiative. And can you share the feeling or from your student?
Okay.
How is
it? Yeah, good you're asked, because I want to clarify that this is for faculty, not for students. And second, we are suggesting the concept of the workshop and how to do it, but we did not implement it yet, and we're planning to doing this. And this is the next step for us.
Oh, okay.
But thanks for asking.
I have a question. Could I know whether you actually advocate design thinking methodology in your university, or you're actually advocating CDIO framework?
Yes. So we are advocating CDIO in a design thinking mindset. So we're taking CDIO and introducing it in a design thinking workshop. So why we're doing this? We need them to experience CDIO in an actionable way. So instead of just providing lectures or maybe attending the conference or reading papers, which they don't do because they lack of time and so on. And we are suggesting to have a workshop for them in a way that it will be like active and they can interact, work more in teams. And why design thinking is used here is that for the first phase, they first have to understand what is the problem, what is happening here at my institution that I can do to help, what can I do to help? And then you have first to understand the problem, and design thinking provides this. First, you understand the problem from the user, which is the student and other stakeholders. You define it, and then you go to the ideation and finding solution for that. CDIO is helping more in the solution phase. It gives you the standards that you can implement, and this is more in the solution phase. And yes, we want to bring problem discovery and solution finding in one workshop in order to just hook them and motivate them to implement CDIO. Is this answering your question?
Okay. Thank you. Yeah. I have another one which I actually posted in the chat. I look at your process, very interesting. You have day 2 explain CDIO standards map exploration. What is that? You're talking about CDIO standards in day 2, in your slide.
Yeah, exactly. So in this phase, they will explore the 12 standards, and we organized the standards in like a map. I didn't show it because of lack of time, but yeah, we just organized the standards in a map so they can explore the standards and just discover the standards in this map. This map is just showing the standard and a little explanation of it. It's like one visual of all the standards, more in a visual representation than a text box. And that's it.
Okay, thank you very much.
Welcome.
I have a question. What is the time duration of this workshop? Because it has prototyping and implementation. So
yes. We are suggesting 4 days to run the whole workshop and suggesting also timing for each session. But I think this is like the first suggestion. It is flexible and could be adapted depending on how they will deal with the new topic and so on. So first, have 4 days and time slots sessions for each one, and then see if you need more or less time for it. And we are also like just coming up with the concept, and we'll prototype it and test it. So we are also using this design thinking, human-centered design mindset to this concept. So that's the first time I'm participating in the CDIO conference, and I would also love to know how you encourage faculty and how you engage them in taking initiatives and doing things for the institution, and not only focus on the course and the tasks they need to do. So if you can share this with me, it would be nice.
Okay, I found some question in the chat box from Eileen. She said that how will your team be evaluating the success of the teaching team implementing them in the class or lessons?
Okay, what I get from the question is how we will be evaluating the workshop after we implement it.
Yeah, like that.
If this is the question, we will provide them the feedback, have a feedback session with them, and they can tell us what they liked, what they wish for, what they lack as well. And yeah, just provide us feedback on how the workshop was for them and the whole timing, and if they are planning to join the next session. And this is how to evaluate just if they like the idea of having the workshop on CDIO. So we're not evaluating the ideas they developed or how they managed doing interviews, but more how they liked the whole experience of doing a workshop on CDIO. And building on that, we will iterate the concept and integrate their feedback.
And also, in my opinion, you will check the feedback compared to the how when they apply the CDIO directly, or it's easy it harder than the design thinking process or not, something like that.
Yes, absolutely.
Yes. Okay, thank you very much for your presentation.
Thank you.
Okay, I looking forward to back to the missing Yanli. I'm not sure. She is in the room or not. Hello, Miss Yali. Okay, I think she not yet come to in this forum. Okay, thanks a lot for all of speakers for your contributions and all of the audience for your participation, and keep the section lively. If you have any comment or suggestion to the contributor, you can directly chat to the author in the WUA application. See you next time and have a nice day. Bye.
Thank you very much,
Thank you.
Prof.
Thank you.
Thank you.
Okay.
See you later.
See you. Oh, Varis, just a question. Where can we see the recorded session?
Yeah, recorded.
on Wuva, there is a link to see the recorded sessions?
It's already recorded, but you cannot back to the C later. You cannot.
Okay.
It's like a permission.
Okay.
This speaker is Emmanuel. Can I share with you something? Is it Emmanuel just a speaker? Okay. I'm June, okay, so I am very familiar with design thinking methodology. So what happens is that for design thinking methodology, I think the emphasis is a lot on a few steps, okay. Empathy study, the first part, whereby you know empathy, you find out what is happening. After that, you go on to talk about ideation, what you want to ideate. And then after that, you will come up with a conceptual design and then implementation. So in to my understanding, in design thinking methodology, usually they advocate a multidisciplinary kind of projects, whereby people from with different skills, some of them could be very good at the design skill, drawing, very good at technical skill, very good at communication skill. Together, we work on the project. So, and then the CDIO, what I view the CDIO, it has usually talked about engineering modules. The C stands for conceptualizing the model. Then the D is to know the development. I is implementation. O is operate. So I find that for the CDIO is more suitable for like what they say, like engineering kind of projects, because you really need to conceive all the specification, you know, ask the client what exactly you would like my students to work on the project, and then design the project and then implement. So I find it's a bit overwhelming, you know, if your university try to put in the two together, CDIO and design thinking, is a bit challenging. Because just now you mentioned that day 2, there are 12 standards. It's a lot because one of the standards is assessment. And you put under day 2, I think it's a bit overwhelming.
Okay.
Yeah, this.
Yeah, good point here. What I also want to add to this is we're not taking CDIO in like the technical process of CDIO and using it with students, where I'm using the CDIO and design thinking both on an educator level and more on a meta level of the process. Like the concept, you know that CDIO is about conceiving, designing, implementing, and operating. So you can take this, and it's like the core of designs, the 4 phases. And design thinking also provides the same. You first start to understand the user, you empathize, and then conceive, design, and implement your solution. So here they are not tackling an engineering and technical problem using CDIO, but more designing education and the whole educational concept using this process, if this can bring some clarification. So yeah, we're more on the educator, the faculty, the professor level using CDIO and design thinking than the student. Student comes to the next step. He is like the user of the solution that will be developed from the educator.
Okay, understand.
Yeah.
Because in SP we have 2 different areas. So we have a CDIO as well as the design thinking methodology we use in different areas. Anyway, thank you for sharing.
Yeah, welcome. And just one thing, you mentioned that we need people really good at design, really good at this, and that. Yes, I do agree. We need a multidisciplinary team, but being good is not a requirement because they do it to become good later. So this is only the remark I wanted to
Okay,
to
I understand, but okay, so maybe I correct myself, because for example, in a design thinking methodology, when we talk about social innovation project, we have, let's say, a faculty member who is teaching communication, join this group. We have people from the School of Computing join this group. We have School of Engineering join this group. Then we have School of the Architecture. So that means that particular group, they are faculty member from different schools with the different skill sets to share. So really multidisciplinary. Yeah. Okay.
Thanks for sharing. Thank you.
for sharing. Thank you. Nice meeting
Have a
you.
good day.
Bye bye. Yeah, I see you
See you.
later. Bye.
See you. Bye.
Bye. Bye.